Hi everyone, welcome to this session on image processing for deep learning models. And this will be a demonstration will be held using both PyTorch and TensorFlow. So before we start getting our hands dirty, let's firstly understand why this image pre-processing is important. So now see, basically for the image models, we have got CNNs which are highly popular in use, and all these deep learning models, they are sensitive to input data's scale, distribution, and consistency. As these models, they learn to extract the hierarchical features from images by identifying patterns from different portions of the image. So if your input images vary in size, brightness, contrast, or orientation, then the model will struggle to converge effectively, and it will not be able to learn the features or to generalize well to the unseen data. Therefore, it is very important for image pre-processing, so that we feed the images in a standard format, a normalized format to the model, so that the gradients they converge. So, what are the important steps in the image pre-processing? First is the standardization of the input, for example, the size, shape, then the normalization of pixel values, because your data, real world data, will have pixel values from 0 to 255. Now, as these numbers are large, so we know that when the gradient loss will flow back, then the gradient will be large. Therefore, it is important to normalize these pixel values either in the range of 0 to 1 or -1 to 1. So this 0 to 1 and -1 to 1, it will depend on your task. So for example, if you are doing a GAN, then you might have to uh, keep it from -1 to 1. Otherwise, for normal image pre-processing, 0 to 1 works. Then often your images, they contain the noises, and this noise can be the sensor noise, or it can be compression artifacts. So we have to have pre-processing techniques to mitigate this noise. Then we also can enhance the features. For example, if you want to extract features from edges or from the textures, then depending on the task, we can include those image pre-processing steps. Now, data augmentation is a very important part, because if we are training the model on a specific set of images, for example, all the images are having images only in vertical dimension, then if in the test data set there is an image which orientation is different, then the model will not be able to classify that or to work on that. Therefore, it is important that we augment the data. And how we can do that? We can carry out certain transformations like rotations, flips, zooms, crops, random crop, center crop, so that our model becomes robust, and this will help to avoid overfitting, and it will improve the model's generalization capability. Then to enhance even computational efficiency, like for certain models, we can convert the images to grayscale, or we can reduce the image dimensions, so that our computational cost can come down. So these are the main reasons basically for the pre-processing of the images. Now, what will happen if we don't do? First of all, I want to mention that pre-processing of images is mandatory. We cannot go ahead without pre-processing. And if we don't do, then what will happen, that either the models, they will exhibit slower convergence during training, or they will achieve lower accuracy, their generalization performance will not be good, they will be prone to overfitting, and they might require more computational resources. So with this background, now let's move to the practical part. So what we'll do first, we will first import the necessary libraries. So I will explain the libraries. So we import OS, NumPy as NP, import Torch Vision. So Torch Vision is the main library from Torch family, which contains a module called transforms. And in that transforms also, we have got their new module, which is known as V2, which has got all these techniques for pre-processing. So we are importing that. Then we are importing TensorFlow, and then from TensorFlow datasets, we are importing them as TFDS. We are also importing matplotlib image as MP image, and we are also importing pyplot for the display. For certain portions, I'm also importing image from PIL, and I'm also importing SK image. From SK image, I'm importing data basically to load a single image on which I will demonstrate the pre-processing steps. Okay, so let's go and run this. Okay, so all the libraries have been imported, and we can see PyTorch version is 2.8, TensorFlow version is 2.19. That's good. Now let's first acquire a simple image. So for that I will use skimage data. So from skimage data already have imported that as data. I will load the astronaut. So this image is available in skimage.data. So this is images of an astronaut. And let's see what is its shape. So just by using image.shape we will get. So shape is 512, 512 and 3. So what is the significance of this? This is in the format of height, width and number of channels. So we can see height is 512 pixels, width is 512 and it has got 3 channels. So we can see from the image also height is 512, width is 512, it is a square image and it has got 3 channels which are in the format of RBG. Okay, so now if we want to reshape this image, so for the reshape we can just use the function image.reshape. Thereafter we give image.shape, for example 0 and -1. What does it mean? Image.shape 0 means it will keep the height, this 512, and rest all it will convert into one dimension. So this will convert to 512 into 3. So your width will become 1536. So let's do this and check this. Yeah. Okay. So see, we can see the height remains same 512 and 1536. And now due to the channels, they have been merged with the width. So see the information coming out from the colors that has blurred now. So all the 3 channels. So it's a grayscale image, you can say. So this was how to reshape. Now we come to the next function, which is known as resize. So we can do resizing of an image using OpenCV. We can also use PIL, and in fact we can use skimage also. So let's do that one by one. So if we want to use OpenCV, then we import first of all CV2, and then we give the new dimensions to which we want to convert the image. So function is resize image is equal to cv2.resize. This is the function. Then we have to give the original image. Then we have to give new dimensions in form of width and height. And we give interpolation is cv2 inter area. And let's see what is the, how does it work and how it will show. So see, we have got the resized and the output is 100, 203. So 100 we had given height, 100 is height, 200 is width and number of channels is 3. And now from here also you can see that your height is 100 pixels, width is 200 pixels, so it has become rectangular in shape and all the 3 colors, all the colors are visible, so all the 3 channels are available. We can do the same activity using PIL. So from PIL first we import image, then we convert our image into the PIL format, and for that function is image is equal to image.fromArray and we give our image. So now it will be in a, it is a PIL image, this image one, and then we convert it to by using resize image1.resize and we give the dimension. So see here we are giving width and height, so it is like CV2 only, resize and then we give width and height. Then again now for the display to visualize it with the matplotlib, we have to convert it back from PL image to numpy array. So we use np.array to get it. Okay, let's see this. Okay, so see here also we have got resize image shape is 100, 200 and number of channels is 3. So this was using PIL. We also can use SK image from where we loaded this image. So it has got SK image.transform.resize and then we give same image and we give, here we give height and we give width. So this is the only difference. In PIL and in CV we are giving width first and height later. Here in skimage.transform.resize we give height first and width later. And you can see this is height, width and number of channels. So that was for the resize. Now there are certain tasks where we might have to reverse the color order. For example, if we are pre-processing an image which we have obtained from an SAR camera used basically by the satellites, so for those frameworks we have to use BGR, so instead of RGB. So for that we might have to reverse the color order. So we can do that by using just image BGR is equal to image, and here we are changing the order. So your from this B has come from second position, it was there, it has come to 0th position. G green remains at the same and R goes there. So let's see how does it look like. Okay, so see now the blue has come in front and this is a BGR image. So by just using the simple NumPy array functionality, we have been able to change the color order. Okay, so for some tasks we might have to use grayscale. So for that we have got a function from skimage.color.rgb to gray. Simple, and we pass image as a parameter and we will get a gray image. Okay, so see we have got a gray image. So we have seen till now reshape, we have seen resize, and we have seen how to change the color orders. Now all this will depend on your task, the kind of task which you have got or the assignment which you have got. Now we will come to PyTorch, how to do image pre-processing in the PyTorch. So like I mentioned earlier, PyTorch has got torchvision.transforms, that is a module which has got transforms, and it has also got V2, and it has got all the functionalities to build a pipeline. So how do we do that? First of all, we have to convert our image to a tensor, and for that your function is v2.toImage. So this toImage will convert your original image into a tensor, and thereafter by using v2.compose we can make a sequential pipeline. Sequential pipeline means that first this, for example, v2 to d type, we are changing the data type to uint8. Then it will do v2 to dot random resize crop. So what it will do, it will randomly resize and it will crop, and it will the height will be 224 by 224. Then we do random horizontal flip by 0.5, that is the 50% of probability. Then we do v2 to d type, we are converted to float 32, and then we normalize it. So here we are passing this mean and standard deviation. These numbers are basically for all the images of the ImageNet. They are having these mean figures, and these are the standard deviations. Now after having this pipeline, now we apply this pipeline to our image, and now we can see what is the shape, what is the min, max. So see, it has been applied, and like I had mentioned here, 224 by 224. So shape has become 3, number of channels 224 by 224. The image min value is minus 2.11 and it is 2.60. So this has come from the normalization. Now to display this, now we have to unnormalize this. So for that we are having the mean and we are having the standard deviation, and the pre-processed image, now we are unnormalizing it by multiplying by standard deviation and adding up to mean, and then we are clamping the values between 0 and 1. So let's see after unnormalizing it. Okay, so this is our image which we have obtained, and I would like to mention here that here we had random resize and random crop. So every time we apply this, we will get a different figure or different image. So here now we do this. Okay, so we can see we have got a different image. So this is by image transformation using a sequential pipeline given by torchvision.transforms, and we can use v2 from there. And I will encourage everyone to go through the documentation of v2. It has got many much more techniques for image transformation. Okay, so after seeing this PyTorch, let's move to TensorFlow. So like PyTorch has got torch vision dot transforms, in TensorFlow we have got tf.image, that is the module which provides a comprehensive set of functions for image manipulations. And how we can do that? So it is also very similar to PyTorch. First we convert the image to tensor, and here only we convert the data type also to float32. So the function is tf.convert to tensor np.array original image which is there, passing the parameter d type is equal to tf.float32. After that, now in the TensorFlow we need our image which was in the format of HWC, that is the height, width and channel, but in TensorFlow we need a batch dimension also, so we have to add a dimension. So here I use tf.expand dims which will add a dimension, and at what place? As 0 place. So this adds a dimension. Thereafter image.resize, it will resize the image to 224 to 224. Then we normalize the pixel values between 0 and 1 just by dividing by 255, and then also we can normalize between -1 to 1, as I mentioned earlier. Many models like GANs, they need in this range. So for that we have to do normalize into 2 -1, so it will come from -1 to 1. And now for the display we will use the 0 to 1 normalized image which we had done here. So normalize TF image. So and then we remove the batch dimension for the display, and let's see how does it work. Okay, so this is the image. So here there is no randomness, so every time we run it we will get the same image. Okay, now like a PyTorch, we also can make a pipeline also. So for that we have to use tf.keras.sequential. So what we do first we define a normalizer. So we have got tf.keras.layers.normalization, we pass the mean and we pass the variance, and x is equal to -1. Then like we did for PyTorch, now we build a pipeline. This is built by using tf.keras.sequential. So first it will do tf.keras.layers.resizing 256 to 256. Then it will do random crop. So first it will increase the size to 224 into 224 and then does random crop. Then we do horizontal flip. Then we do random contrast. 0.2 means it will be from 0.8 to 1.2, that is delta. Similarly random brightness, and then we do rescaling to 0 to 1 by dividing by 255, and then we normalize. So normalize, okay, already we have written a function here, normalizer, so we apply normalizer. So this is the pipeline. Now this augmented image, we apply this pipeline by using tf underscore pipeline which we have defined, and we apply on our original image. But before applying this pipeline, we have to expand the dimensions to include the batch. And then for display, we remove that batch dimension. Then we denormalize for the display by image into standard deviation plus mean. And this is the display image, which is the denormalized. We have added a function, and then we clip by value 0 and 1, and then we display it. Okay, so see, now again we have got a randomness here, so we can see we will have get different images, so we can see. So like a PyTorch, we can also build a pipeline in TensorFlow also using tf.keras.sequential. Okay, so now we are done. So now this was a function I explained which we were doing only on single image. But for example, I want to have, I want to augment my data with a lot of images by these transform. So what I can do, I can run in a loop to get those images, and then after that I can concatenate that data to my data set. So for that, just I have to do for I in range 5, so I'll get 5 images. This is the same PyTorch v2 transforms which I had written a pipeline using PyTorch, and then I am applying to the image tensor. and then for the display I'm denormalizing it, and then I'm using matplotlib to plot it. So see, I've got these 5 images. Now if I save these 5 images, or I take for example 100 images or 200 images depending on my task, I can add this augmented data to my data set. So my pipeline had randomness, so every time I use it I will get a different images. Okay, so this is how I can get augmented data. Now same thing I can do using TensorFlow also. So for that I have defined a function in which I have got all the functionalities to resize, random crop, random flip, random brightness, random contrast. It is there, or I can use my pipeline also which I had defined. So here I do for TensorFlow also I can get the augmented data. So in this also I have got random, so every time I run I will get different data. So this is how I can generate augmented data for in TensorFlow. Okay, so this is same. This is using my pipeline. So here I had written a function. Now I'm using my pipeline which I had used tf underscore pipeline, which is a TensorFlow pipeline using tf.keras.sequential. So see here, this has also given me 5, and every time I use it, it will give me different images. Okay, so this is how I can use the PyTorch pipeline, or I can use TensorFlow pipeline to get the augmented data set. Okay, now just to give you the basic transform using PyTorch. So v2.2 image, it converts to tensor, then it converts to data type intate, random resize crop, or to d type float32, and to normalize. So these are the standard steps, and generally in a typical training environment, it will give you a good performance when you're using the data loader from torch.utils.data. And other transformation, it will depend on your task. So you go through the V2 documentation, it has got many functionalities, many transformations, and you can play with that. Okay, like I have mentioned here, like other V2 functions, resize is there, scale jitter is there, random shortest size. So please go through that, and then you can download one image and you can play with that. Okay, just to give you a demonstration for random, center crop. So it has got a center crop also. This center crop v2 dot center crop size. So it cuts the crop the input at the center. So for example, I have defined a new pipeline. I am resizing to 100 size. Then I am doing center crop for increasing the size to 256, and then it will crop. The random horizontal flip I am giving with probability 50%, converting to data to float32, normalizing it. Then I am applying this to image. Then to for the display I am denormalizing it, and let's see how it will work. Okay, so see, it has increased the size and then it has brought the image to the center. So this is just one example, and you also can work with various other functionalities given in the V2. Okay, so till now we have seen working on in single batch for single image. Now we will work in batches. So batches, it is also quite simple. For example, using PyTorch, you define a pipeline, and then while downloading the data, then you use this pipeline with a parameter transform. So I have defined this pipeline transforms, I have added these functionalities, and now when the data will be downloaded from data.train from the CFA dataset of torchvision.datasets, already it will get. Okay, so it has happened, and now to see one image. So first of all, I have written data mean and data standard deviation. I have defined a function unnormalize, and then to get a batch, I am using a data loader. So data loader I am defining with a batch size of 16, means 16 images. Number of workers, that is the number of CPUs needed, will be 2. Then I am getting image batch and labels batch by using iter data loader. So it will give me one batch. And now from that I am getting the first image from the image batch 0, printing image dot shape. Then I am unnormalizing it for the display. Okay. Okay, so I've got the first image. Okay, and then if I do it again, then I'll get the next image by using iter. Okay, I've got. Okay, now we can see what are the shapes of image batch size. So it is 16 number of images in a batch, channels, height, width. Labels batch size is 16. We can see the batches. Okay, labels, so they are from 0 to 9. Now to see one batch image, all the images in one batch, I will make a grid. So image is equal to that torch vision utils dot make grid. So what it does in the make grid, uh, it has got two default parameters. So it has got default parameters n row is equal to 8. It means I will have 8 images per row, and padding is equal to 2. So when I'm creating this image batch, so these are the number of channels. This 454 is the height. So I've got 16 images in a batch, so and 8 images in one row. So I'll have 2 images vertically, and the size is 224. So 224 into 2 is 448. Then there are 3 paddings, one padding on top, one padding in center, one padding below. So that's why size becomes 454. Similar calculation you can do for the width also, it will come same. Now for the display, I will convert it to transpose image dot shape. I will bring it to height, width and channel. Then I unnormalize it for the display and I display it. Okay, so I have got these images from one batch. Okay, like I mentioned earlier, there are 8 images in one row. These are the dimensions. So this is a full code with everything at one place. Okay. Now in the TensorFlow, the same thing I can do using either I download the dataset from Keras dataset or from TFDS, that is a TensorFlow dataset. So if I use the Keras dataset, first I do autotune is tf.data autotune. What it does, it automatically it will tune the parallelism, that number of workers, everything. I give the data mean, data standard deviation, then I download the data, then I define a function for all the transforms, and then batch size, and then I'm downloading trend.ds, I'm applying this and preparing. Okay, so let's see, it will download and then we can view the images. Okay, so I've got, these are the of one batch 16. Now similarly I can do tfds. In that, first I define augmentation pipeline. These are the augmentation and this is the pre-process pipeline. So for my test dataset, I will not need augmentation pipeline, so I will not apply that. Then I define a load CFAR with pipeline. The train DS, it has got augmentation, whereas in the test DS it has got only pre-process pipeline. And then I can, okay, and we can see it will also load and it will also give us. Okay, yeah, it has come. So I have added one more function here which handles both the cases, the TFDS also and Keras dataset also. So that I will leave up to you. You go through that. So with this, friends, I have finished this demonstration for pre-processing of images. So in conclusion, I would like to say, first of all, pre-processing is mandatory. It is mandatory for all your vision tasks to train all the models, and primarily PyTorch has got torchvision.transforms.v2 and TensorFlow has got Keras. Thank you and have a very nice day. Happy learning.